In this video, we're going to talk about curve sketching. For these problems, we always need the information from the first and second derivatives, so we're going to go ahead and compute those first. Now that we've computed the first derivative, we can compute the second derivative. Great. Now, we want to figure out where we are an increasing and decreasing function. So we're going to just recopy these derivatives real quick. Okay, now that we've computed our first derivative, we have something to think about. First of all, the function x squared minus 1. We'll sketch this. It's a nice parabola, and it has two roots. Our roots occur at -1 and +1. For both the derivative and the second derivative, observe that when x is between -1 and 1, both f prime and f double prime are undefined. So they're undefined at -1 and 1 because we would have a 0 in the denominator, and we are undefined on the open interval from -1 to 1 because in both cases our denominators take square roots of negative numbers, which is not going to work. So our next observation is if we want to find out where we are increasing or decreasing, that's going to be determined by the sign of the denominator. So wherever the denominator is actually going to be defined, that's to the left of -1 or to the right of +1, x squared minus 1 is a positive function. So that means its square root is positive and its cube is positive. Since we have a -1 in the numerator, that means that f prime is always going to be negative. So our function is decreasing on the interval -∞ to -1, union with 1 to infinity. Okay, next we have to think about the concavity of our function. So the concavity is dictated by the second derivative, which we're going to move down here so we can keep it going. Okay, so similarly, this function is only defined to the left of -1 and to the right of +1. In both cases, the denominator is going to be a positive number. So the sign of our second derivative is determined entirely by the function 3x. So this tells us the concavity switches. So we are concave down from -∞ to -1, and we are going to be concave up from 1 to infinity. We note here that we do not get any inflection points. The reason for this is our concavity will actually change around our two asymptotes rather than at a point where the function is defined. The last piece of information that we need in order to be able to sketch our function is the limits at infinity, whether or not there are any horizontal asymptotes. That's our last piece. For that, we're going to grab our function once more. So here's our nice function, x over the square root of x squared minus 1. And we're going to compute the limits as x go to positive and negative infinity. Before we do that, we want to make a careful observation. And that observation is that the square root of x squared is the same thing as the absolute value of x. This is going to become important. So we're going to compute the limit as x goes to infinity of our function f. Now we observe that because x is tending towards infinity, we're assuming that x is a large positive number. So that means that x divided by its absolute value is 1. This says that our function f has a horizontal asymptote at the line y equals 1. When we compute the limit as x goes to minus infinity, we're going to actually find that we get a horizontal asymptote not at 1, but at minus 1. And the reason for this is when x is a large negative number, x divided by the square root of x squared is actually going to be minus 1, because x and its absolute value are the same in magnitude, but the opposite in sign. Now we have our other horizontal asymptote at minus 1. So this says that as we look far out to the left, our function is going to be approaching minus 1. In order to sketch the curve, we need to collect all of our information. So we're going to do that real quick. Great. Now that we have all of our data, we're going to get a little graph paper here, and we're going to use this information to sketch our function. Great. Now we have all of our information together with our asymptotes. So first thing to note is that our function is going to be a decreasing function everywhere that it's defined. So it's going to be defined to the right and to the left of our two vertical asymptotes, x equals minus 1 and x equals 1. To be a decreasing function and to have these asymptotes as well as being concave up to the right of 1 tells us the only place that this can possibly happen is going to be in the first quadrant. So to sketch it, we're going to start with our asymptote here, being a concave up function, tells me as we approach positive 1, moving from right to left, our function is going to go to infinity. So it's going to decrease as we move from right to left, and it's going to approach this asymptote here. That's the only way that we can draw such a thing, which is both decreasing and concave up, and approaches both of these asymptotes. Similarly, because we know our function is concave down to the left of minus 1 and decreasing, the only way that we can do this is to approach minus 1, y equals minus 1 from below, like so, and approach our vertical asymptote this way. So our function is going to decay towards minus infinity as we get towards minus 1. That's it. That's our nice sketch for the function y equals x over the square root of x squared minus 1.